Okay, so we're still working with parallel and perpendicular linear functions. And today I want to focus a little bit on the horizontal lines and the vertical lines. So the horizontal lines, let's start with them. They're the ones that cross through the y-axis, okay? And they have a slope of 0. So the slope is 0 for horizontal lines. And the equation, since it goes through the y-axis, is we have a y value that it crosses through. So we want to put it a y equals a number, but it has 0 for the slope. And so 0x is 0, and so we don't really write that down when we write our equations. So it's y equals, and then the number that goes through. So this is the y-intercept, which we also often call b. So in the y equals mx plus b form, okay? But we have a 0 for our slope, and so 0 times x is 0. So all we left is with the b. The vertical lines are the ones that cross through the x-axis. And these are actually not functions because they have repeating x's. So the slope that goes up so much and over 0 is going to be undefined because we cannot have a number with the denominator of 0. So the vertical lines have a slope that is undefined. And the equation for a vertical line is x equals, and I'm just going to put a c right here, some constant number. So the one above, it's x equals 2. And the graph here is y equals -3. Okay, so all horizontal lines are parallel to each other. They all have a slope of 0, and if you have the same slope, your lines are parallel. So I'm just going to write that down anyway, though. All horizontal lines are parallel. Okay, and then all the vertical lines are going to be parallel. They all have the same slope. It is undefined. Okay? All vertical lines are parallel. Okay, so horizontal and vertical lines are always perpendicular to each other. Okay, their slopes obviously would not multiply to equal -1, but they are perpendicular, okay? So let's look at these example problems that I have and determine if the lines are parallel or perpendicular. So we have x equals 4 and x equals -2.
Those are parallel
And so why do you say that?
because both of them have go on a different x value, which means, and since they have 0 slope, they stay flat, and which means they don't intersect and they don't intersect at all, which makes them parallel.
Good, they are parallel. But they are the vertical lines. These are the vertical lines. Okay, so they both have the same undefined slope, right? So they were flat this way, right? Yeah.
Yeah, that's what I meant.
I know. Okay, so these are vertical lines. And so they both have, they both have the same slope of undefined. Okay, what about y equals 7 and x equals 5? So we have,
It would be perpendicular.
yeah, these ones are going to be perpendicular because this one is the horizontal. And this one's the vertical. And they're perpendicular. Okay, so on this one, let's solve for these. So we want to solve for, you know how we just go and solve for y? That's what we'll try to do. Okay, so I'm going to subtract, I'm going to write this one 6, let me write it in a different color, just so we're keeping things together here. So we have 6y plus 9x equals 6y plus 9. So if I subtract 6y from both sides of my equation to get them all to the same side, I end up with 0 equals 0. I mean, 0 and 0, they both cancel out, is my point. So I have 9x equals 9. So I guess I'm solving for x because there's no y left. It canceled out. And therefore, I'm going to,
Equal to 1.
exactly, we're going to divide both sides by 9, and we get x equals 1. So that would be this equation. Now let's do the second one. So that's 3x minus 2 equals 3 times x plus y. So we're going to distribute 3x plus 3y and 3x minus 2. Okay, so we only have y's over here, so let's get rid of everything else that's not next to the y. Because that's what we think of when we're doing this, right? We're solving for y. So since there's only on this side of the equation, we'll just bring it all over here. So I have minus 3x minus 3x. So those cancel, so I end up with negative 2 equals 3y. Then we'll divide by 3. And we have y equals negative 2 over 3. Okay, so what do we have here? X equals 1 is the one that goes through the x-axis at the 1, and the y equals negative 2/3, so it's below the 0, 0, but it still only crosses the y. So I have a...
Those are also perpendicular.
Exactly. Because we have a y equals a number and an x equals a number, and they're always going to be perpendicular. So this is vertical, and this is horizontal. And so we have perpendicular. Vertical and horizontal lines are always perpendicular to each other. Okay, so again, parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocal. So like 1/2 and -2. Because those are opposite, one's positive, one's negative. And then if I flip over 1/2, I get 2/1, but I don't have to write that over 1 thing. Okay, and then also perpendicular lines are horizontal and vertical are going to be perpendicular. Okay, so also we want to make sure we know the point slope form, right? Because we keep using that. So that's y minus y1 equals m times x minus x1. So once we know the slope that we want, remember we did the steps yesterday. First we get the slope of our original equation. If we have to rearrange the equation first, that's fine. But we get the slope of our original equation, then we decide if it's parallel or perpendicular, and we either keep the same slope or we flip it over. And then we plug it into the point slope form if we want to go through a certain point. So we take our slope and our new slope and we put it there, and then we plug in our x1 and y1 of what we want the line to go through, and then we get our equation. We may have to keep solving for y if we need it to be in that form, in slope-intercept form. Okay, I might as well write that formula down too. Slope-intercept form is y equals mx plus b.